Hello everybody. Today I will discuss on theory of consumer behavior. This is the part of your semester 1 intermediate introductory microeconomics for both core 1 core paper and for general paper. Okay. Now here today I will tell you a story of you, me and all of us. How we behave as a consumer towards economic goods. When we consume a commodity, how we actually behave. Now, when we are talking about the economic good means the product that we need to buy by paying some money. Okay. Now, in this particular scenario in economics, we will consider only talk about economic goods. Now, the question is why at all we consume and why we will pay money for the consumption of something. Well, the answer is we consume because we get utility or satisfaction after out of it by consuming a product. Okay, I am giving you an example. Well, this utility is different for different people. Different people behave differently for a particular product. I am giving you different example for this. Like suppose everybody, all of us like to eat something, right? So, suppose you like to eat ice cream. Now, consumption of ice cream will give you a certain level of satisfaction. This is your utility. Now, suppose person A and person B. There are two person. Person A like to eat chocolate and person B like to eat ice cream. Now, consumption of one scoop of ice cream for both person A and person B will give different level of utility or satisfaction. Now, utility of consuming a commodity varies. That is why I am saying that utility of a commodity varies person to person. Again, utility will be different with different quantity. Like for example, again I am giving you one scoop of ice cream, you will get a certain amount of satisfaction or utility. Now again I am giving you the second scoop of ice cream, you will feel more happy and you will be more satisfied. So, one scoop of ice cream and two scoop of ice cream giving you different level of utility or satisfaction. Again, utility can varies with different choices. Again the same example, chocolate and ice cream. If you like more chocolate, you will prefer chocolate, eating chocolate more when you have option to buy both at same price. Suppose you have given 10 rupees to buy chocolate or ice cream, you will definitely prefer that what you actually like. Okay. Another is a person can have different utility from the same good of the same product at different point of time. For example, suppose you like to eat rasgulla. Now, immediately after waking up from bed, you offered to eat a rasgulla and you will get certain amount of utility. The same thing, same product you have offered after a very good lunch. So, that is another level of satisfaction, but this rasgulla at immediately after waking up from bed or after having a good quality lunch, this utility level will different. And again another example is like winter garments. Okay. winter garments, it has only we use winter garments only in winter, right? There is no utility of winter garments in summer. Well, these are some example of utility. Now the question is, why we are talking about utility and why we are studying this? The point is, in economics, our main target, our main objective is to understand the demand curve. Okay. Now, demand curve, when we get utility by consuming a product, then we get satisfaction out of it and we demand for that product. Now, this demand differs with respect to price. So, demand curve is the relationship between price and commodity consumed. So, I am creating my own demand curve, individual demand curve for a particular product. So, this is how my own personal choice is making my own demand curve, individual demand curve, my individual demand curve, person A, person B, person C, all together when we are combining, then it is becoming the market demand curve. And in economics, our main objective is to understand this demand curve. Okay. Now, in economics, there are two utility approach given by Marshall and Walrus: cardinal utility approach given by Marshall and ordinal utility approach proposed by Walrus. Now, what is cardinal utility approach and ordinal utility approach? Cardinal utility approach is when we can measure utility by using cardinal number, that is 1, 2, 3, etc. That means we can measure numerically our own level of satisfaction by consuming a particular product. And second is ordinal utility approach, that is when utility is only rankable but not measurable. In cardinal utility approach, utility is measurable as well as rankable. We can rank that, okay, this one I prefer more, this is giving me 7 units of utility, this is giving me 5 units of utility. So, this 7 units is more than 5 units of utility. But in ordinal utility approach, we cannot measure utility, but we can rank utility. This is rank 1, rank 2, rank 3, and according to this we decide. Actually, ordinal utility approach is more realistic, because in real world we cannot measure utility by numeric number. But we will start from the very basics, and that is why we are starting. If we can measure our utility, then what will happen? If we can measure utility, then how demand curve can be derived? Okay. Now, coming to the cardinal utility approach proposed by Marshall, there are certain level of assumptions. Okay. Here are 6 assumptions. These are each and every point is very much important to understand the model properly. Okay. Utility, first one I have already discussed, that is utility is cardinally measurable, that is we can measure our utility by assigning number. Okay. Consumption of commodity X gives me 5 units of utility, consumption of commodity Y gives me 10 units of utility. So, I can measure the utility by numbers. Second one is marginal utility of money remains constant. What is that means? Is that margin? Well, whenever I am talking about the word marginal, this is mean change. Marginal means change always. Marginal utility means change of utility. Marginal utility of money remains constant. it doesn't mean that when I am having 1 rupee coin or 2 rupee coin or 3 rupee coin, my utility is not changing. This is not the case. The point is, suppose if I have 1 rupee coin, I am getting 2 units of utility. As I am talking about cardinal utility approach, that is why we can measure utility. That is why I am telling, suppose I have 1 rupee coin and that is giving me 2 units of utility. I have 2 rupee coins, it is giving me 4 units of utility. I have 3 rupee coins, it is giving me 6 units of utility. So, having money more and more, it is increasing my utility more and more, but this change of utility from 1 rupee to 2 rupee, from 2 rupee to 3 rupee, change is same, that is 2. Okay. That is why change of utility, that means marginal utility of money, remains constant. This is the second assumption of cardinal utility approach. Okay. Third one is the law of diminishing marginal utility. This is very much important and I will discuss it elaborately later, but just giving you an idea. Law of diminishing marginal utility means whenever we consume an extra amount of commodity, then our utility level increases, but change of utility decreases. Okay. Change of utility decreases. What does that mean? Suppose consuming 1 unit of a product X, say consuming 1 unit of X product gives me 5 units of utility. Okay. Consuming second unit of product gives me suppose 8 units of total utility. Consumption of third unit of X product suppose gives me 10 units of utility. So, I am changing from my utility is changing from 0 to 5 to 8 to 10, but this change of utility shifting from 0 to 1 unit, 1 to 2 unit, when we are shifting from one consumption of 1 unit to 2 unit, then my change of utility is 3, 5 minus 8, 8 minus 5, 3. Again, when I am shifting from second unit of consumption to the third unit of consumption, my total utility is increasing from 8 to 10. So, here change is 2. So, change of utility is decreasing. Okay. 5 to 3 to 2, well, I will discuss this portion elaborately later. This is called law of diminishing marginal utility. Fourth one is utility obtained from any commodity depends only on the amount of consumption of that commodity and independent of presence of other commodity. That means utility from consumption of A and utility A commodity and utility from consumption of B commodity is absolutely independent. My own personal utility on chocolate and ice cream is different and it is not interdependent, it does not affect each other. Okay. And fifth one is very crucial, that is a consumer is rational and his aim is to maximize utility. Whenever I have budget, suppose I have 10 rupee coin and I have to choose between A and B goods. If I can understand that B goods give me higher utility, I will definitely go for it, not for A, because I am a rational consumer. Okay. So, always my aim is to maximize utility. Sixth one is money income of the consumer and price of the commodity he consume are fixed and constant, cannot be changed by consumer. A simple thing, money income and price of the commodity is fixed, it cannot be changed. Okay. Now coming to the model, suppose a consumer consume small x unit of capital X good. This is unit of goods and this is name of the product. Okay. Small x unit of capital X good and getting u amount of utility. Okay. Then u is function of, u means utility is function of this x. Okay. Now this is our utility function. Marginal utility, that is, I have already told that marginal, whenever I am talking about marginal, that is change. Marginal means change of utility, that is du del u del x, that is mu x. This is positive. Okay. In your class 11-12 you have probably learned this idea of differentiation, that is dy dx. What is that? This is change of y due to 1 unit change of x. Here we are considering utility. So what is this? This is change of utility due to 1 unit consumption of x commodity, and that is the marginal utility. Okay. My marginal utility should be positive. Okay. If my utility does not, if my marginal utility is not positive, then I will not want to consume that. That means what is marginal utility is negative, that means when I am consuming something, then my utility is getting low. So I will not consume that product. And second is rate of change of marginal utility is negative, that is the diminishing rate of marginal utility, law of diminishing marginal utility, as earlier I have discussed in the third assumption, that is law of diminishing marginal utility operates, and this shows the result that rate of change of marginal utility is negative. How I will calculate that rate of change of marginal utility? That is nothing but du dx, that means the second order derivative of utility curve, utility function, this equal to d2u del 2u del x2. Okay. This should be negative because I have said that there exists diminishing marginal rate of utility. Now x is positive. What does that mean? That means the utility curve should be positive, upward sloping. First order condition is positive, that means slope is positive. Okay. Second order condition is negative, that means the curvature is concave to the horizontal axis. The curve will be look something like this. Okay. This is utility curve. Now look that this is slope, this is slope at this point, this is slope at this point. Now look that this angle is reducing, this is positive, that is why first order condition is positive, marginal utility is positive and slope is positive. But change of slope, that means point, this point to this point, this point to this point, change is slope is positive but change is reducing. Look, this angle is greater than this angle and this angle is greater than this angle. That means as I am moving to upwards, my angle or the slope is reducing. That is the second order condition, that change of marginal utility is negative. Okay. Now, giving you an example, elaborating the law of diminishing marginal utility. Suppose initially I am consuming 0 units of product, that means I am not at all consuming any product, okay. That is not giving me any utility. Left hand side measured the number of quantity of consumption, total utility getting out of it, and the marginal utility. If I am not consuming, that means I am not getting utility, 0. 0 consumption, total utility is 0. First unit of consumption of a particular commodity, this is giving me 6 units of total utility. Second unit of consumption of commodity giving me 11 units of total utility. Again third giving me 15, fourth giving me 18. Well, look, marginal utility, here utility is positive, okay. Marginal utility from 6 to 11, from 0 to 6, 0 means when I am not at all consuming. From the first, from nothing consumption to the first consumption, it is giving me 6 units of utility. That means change is 6. Again change for the second consumption, change is 11 minus 6, 5. Third, again the change from 15 to 11, that is 4. So, change is positive, but it is reducing from 6 to 5 to 4 to 3. Now, the question is why this happened? And is it true for all? The question is most of the cases yes. And why this happens? Because this is our human nature. Giving you example, suppose you like to eat rasgulla, okay. Now I am offering you first unit of rasgulla and you will feel very happy and you will have 6 units of utility, say. Now offering you second unit of rasgulla and again you will feel happy, but from moving from 0 to 1, what was the shift? That time that much excitement, your happiness will little bit reduce, little bit, not much but little bit reduce, and the total utility will 11. Okay, so first time your utility was, change of utility from 0 to 1 unit was 6. Second time your change of utility is 5. Again another one, someone offered another rasgulla, again you will feel happy, but the change from shift from second consumption to third consumption, third unit of consumption, your happiness will increase, but not that much as the previous one, okay. So, this is just the human nature, that as we consume same product more and more, our happiness increases, our utility increases, but rate of change of utility diminishes, okay. Now, suppose you have your capacity is 5, you can eat 5 rasgulla at a time. Now again someone comes to you and offer you another rasgulla 6. That time you will feel a little bit tired and probably that will not increase you any utility. You will not just, okay, giving, I am eating, okay. No extra utility will add, you will remain at same level of utility, and that is the case. Look, your consumption of 4 to 5 units, your utility was 20. Consumption of 5 to 6 units, your utility was again 20. That means you have no change in happiness or satisfaction. Now at this point marginal utility is 0. Okay, this is the case where marginal utility means slope of utility slope of utility curve at point 6 is 0. Okay. Now suppose at this point again someone offered you another rasgulla, that is 7 units of rasgulla. At this moment you will feel just tired and don't want to have that rasgulla, and it will start taking this 7th one of product. You will feel your utility will start to reduce. You were at 20 units level of utility, your utility will fall and you will reach at 18, and that is why marginal utility is negative. This is just human nature and you can follow, almost all of us react like this way for most of the products and most of the cases. Okay. Now according to our assumption, look, according to our model marginal utility is positive. Okay. As we can see that our assumption is that marginal utility is positive. So this point, this negative part 6 to 7 marginal utility is negative. In this model we are not considering this part. In our model we will consider up to only this portion when our utility is positive as well as our marginal utility is positive. Okay. Now coming to the model, we were considered that we x units of capital X commodity and our utility is u, which is function of x. Okay. Now suppose when we consume something, then we have to purchase that. Okay. Now while we are purchasing something, we are purchasing it by sacrificing some amount of money. So here is a sacrification, loss of sacrifice. We are losing and sacrificing a certain amount of money. So our net utility will be the difference between total utility obtained from consuming the product and total utility sacrificed by paying some money. Okay. Suppose lambda is the utility of unit money, lambda is the utility of unit money. Here in the model assumption we have considered that second assumption, marginal utility of money remains constant. So marginal utility of money, if lambda is the utility of money, then 1 units have lambda utility of money, 2 units have lambda utility of money, 2 units money, 3 units money has lambda utility of money. Okay. So if we suppose the price of commodity is Px, price of commodity X is Px. if the consumer consume X units of commodity, then total expenditure will be X into Px. Okay. That means I am sacrificing X into Px units of money for consumption of X units of capital X commodity. So, our sacrification of money sacrification, utility sacrification from money will be lambda into Px into X. Okay. This will be my sacrifice of utility from giving the money to the seller. Okay. So, what will be my net utility? This is the utility function. This portion of utility I am sacrificing. This portion of utility I am sacrificing. Okay. So, my net utility NU will be difference between my utility and sacrifice Ux minus lambda Px into X. Okay. This will be my net utility. Okay. Now, we are rational consumer. Why? We at the fifth assumption, the consumer is rational, and as a rational consumer, our target is to maximize our net utility, right? Our target is to maximize our net utility. So, what is the condition for maximization of any function? Maximization, first order maximization condition is first order derivative should be equal to 0, and second condition for utility maximization is second order condition will be less than 0. So, first order condition of net utility del nu x del x will be u prime x minus Px lambda. Why? Because Px and lambda is constant and x is variable. So, Px lambda and u prime x is the first order derivative of ux. This will be equal to 0. This is our first order condition. Okay. So, what is this? This is nothing but slope. Well, this is actually del u del x, right? What is that? That is marginal utility. This is actually equal to Px lambda. Okay. This is actually slope of x, slope of utility function. This is slope of utility function ux, and the right hand side is nothing but the slope of monetary sacrification, utility from monetary sacrification. Lambda into Px into x. Okay. So, this is marginal utility. of x, okay, and the right hand side is marginal utility of sacrifice. Look, marginal utility of x is marginal utility of sacrifice. That means when my marginal utility by consumption of a particular product will be equal to marginal utility of spending money, sacrifice for spending money will be equal, then the equilibrium point will be found. And second order, well, my second order needs to be fulfilled. What is the second order condition? The second order condition is the second order condition should be negative. That means second order derivative del 2 net utility del x2, that should be negative. And what is that? This equal to basically u double prime, and this is nothing but this u double prime means second order derivative of utility function, nothing but second order derivative of utility function, and this is negative. Why this is negative? Because we have assumed that there exists law of diminishing marginal utility. Okay. As we have assumed that there exists law of marginal utility, so second order condition is negative, and the utilization maximization condition, second order maximization condition is also fulfilled. So this is the this is the equilibrium condition for the consumption of a particular product. Okay. Now from here, this is the mathematical derivation, and we need to derive it graphically also. Here we can see that the curve of utility sacrifice is straight line for from origin. Why? Because this is utility curve, and we have discussed already in detail about this. This is lambda into px into x. Why this is straight line from origin? Because you can see that lambda into px into x, this lambda into px term is constant. So only this x term is variable. That is why it is straight line from origin. Increase proportionately, lambda into px into x increases proportionately with increase in x. And why it is from origin? If x is 0, then this term will be 0. That is why it is starting from origin. Okay. Now according to the proof, earlier proof, marginal utility of x is equal to marginal utility of money sacrifice. So and also the slope of ux is equal to slope of this lambda into px into x term. Okay. So where the slope is equal, there will be, we will get the equilibrium output level, output or consumption level. Here at this point slope is this, again this, again. By this we can get one point where slope of this and this line is equal. So this point will be my equilibrium level. You can see our main target is to maximize net utility. Net utility means what? this minus this. This is consumption, utility getting out of consumption, and minus utility getting sacrificing the money. So, where the gap is maximum, their net utility is maximum, and as a rational consumer we will consume at that point where net utility is maximum, and this point is this area. Before, suppose this is utility and this is x, okay, this is suppose x star. So, before this point, before this x star, this gap is increasing. So, there is a scope of increasing our consumption, increasing our utility. If I have scope to increase our utility, I will definitely increase my consumption. So, before this point, for each and every point, as a rational consumer, I will continue to increase my consumption, and after this point, as I move towards right from x star point, my consumption, my net utility will fall. These are my net utility. This side it is rising, and when we move towards right, this side it is falling. So, as a rational consumer, I will try to stay at this point where my net utility is maximized. So, x star is the equilibrium point. Okay. Now, as we have considered the total utility curve and total monetary utility from money sacrification curve, we will now consider the marginal utility curve. Marginal utility, there exists law of diminishing marginal utility. That means utility diminishes as we consume more and more. Okay, sorry, utility increases but marginal utility decreases as we consume more and more. So, this will be something like this, marginal utility. This is not utility curve. Utility curve is upward sloping, concave to the horizontal axis. Okay. And as per our assumption, second assumption, marginal utility of money remains constant. If marginal utility of money remains constant, then marginal utility of money sacrification curve will be nothing but straight line, nothing but horizontal axis, straight line and horizontal with respect to x axis, marginal utility. Okay. So, this is the equilibrium point. Why? Because x star, suppose this is x star, from the left of point T, gain in marginal utility is more than loss from marginal sacrifice. This is gain from marginal utility curve, this is loss from marginal utility, loss from marginal sacrifice. Okay. So, before this point, gain in marginal utility is more than loss from marginal utility, loss from marginal sacrifice, and again after this point, this x star or this equilibrium point E, the amount of consumption more than x star, the gain in marginal utility is less, the gain in marginal utility is less than the loss in marginal sacrifice. So, as a rational consumer, I will not move from point x star, I will try to maximize my own utility, my net utility. So, I will stay at this point. Okay. Now, as I have mentioned earlier that our main objective is to derive demand curve, okay, from this utility maximization situation or theory, utility approach, cardinal approach. So, now we will see that how the utility demand curve is derived from cardinal utility approach. Okay. Here you can see that the equation mu x equal to lambda px, where we have found that here, look, slope of ux equal to slope of lambda into px into x, which is nothing but marginal utility of x is equal to marginal utility of money sacrificed. So, from here it is written mu x equal to lambda px. Okay. So, what is demand curve? Demand curve is the relationship between price and quantity. Okay. If it is relationship between price and quantity, then px equal to mu x by lambda. So, mu x is a function of x. So, ultimately this is actually demand curve, because px, look, px is function of x because lambda is constant. If lambda constant, then marginal utility is function of x and price is equal to function of x, and that is nothing but demand curve. But this is actually a rectangular hyperbola example equation. Rectangular hyperbola, what is that? Y equal to ax. If my equation is in this form, a means a constant and x is variable, y is variable, a is a constant. If my equation is in this form, y equal to ax, then my equation will be rectangular hyperbola. Okay. Here is the equation is also in this form, lambda is a constant and px and mu x. Okay. So, this is the same form. So, this is rectangular hyperbola, and my demand curve, our demand curve here will be like this. Suppose price is at P0, x1, x and P. x1 is my consumption. Now, price reduced to P2, my demand will increase. As price falls, demand will increase. So, my consumption level will be increased to x2. Okay. This is rectangular hyperbola, and what is the speciality of this curve? That is, this area means, suppose this is 0, 0 x1 0 O x1 a P0, O x1 a P0, this area will be equal to O x2 B P2. This area will be equal to this area. Okay, this is the speciality of rectangular hyperbola equation. So, we have derived demand curve from in cardinal utility approach. Okay. This is the model, this is the overall model. Now, there are many limitations of this model. Okay. Why? First of all, of course, we cannot, in real world, we cannot measure utility by assigning numbers. It is impossible. We cannot say, in real world we cannot say consuming 1 unit of chocolate, 1 bar of chocolate is giving me 5 units of utility, 2 bar of chocolates giving me 8 units of utility. This is unrealistic. Okay. Second is the fixed, we considered that fixed marginal utility for unit money. This is also unrealistic. Fixed marginal utility for unit money is not, in reality it is not the case, because for poor people certain amount of increase of 1 unit of money will have different level of utility. If he has 0 units of money and he suddenly get 1 rupee and again he suddenly get 2 rupees, this change from 1 to 2 rupees will not same as 0 to 1 rupees. Again change from 1 to 2 to 3 rupees, the utility will not same as change from 1 to 2 rupees. So, this is again another unrealistic assumption. Third one, in reality the utility from consumption of a commodity depends on the presence of substitution and complements, which is not considered in Marshallian theory. We have considered one assumption that each utility is independent for all the products. Utility from one commodity, commodity A, and utility from commodity B is absolutely independent. This is not the reality. In reality, we consume many products and all the products are simultaneously related, that may be complementary, that may be substitute goods or complement goods. So, there exists dependency in utility for different products. And lastly, the Marshallian demand curve is rectangular hyperbola. This I have shown the case, and this is actually a special case. Not always this case cannot be happen. Okay. So, this is all about the cardinal utility approach. Today is my first class on the theory of consumer behavior, and we started with cardinal utility approach. Next we will move to ordinal utility approach, and that is more realistic. And again the class will be continue. See you later.